Hi everyone, my name is Preshayla and today I'm going to be taking you through a GCSE Physics exam question all to do with moments. So here is a kind of typical moments question that we see come up time and time again. The question has quite a wordy kind of introduction and then goes into probably two parts of some mathematical calculations. So there are two blocks of different masses, block A and block B. They're placed on either side of a beam, which is supported by a pivot in the centre. The beam is balanced. Block B produces a downwards force of 280 newtons and is placed at a distance 0.5 metres from the pivot. Block A is placed at a distance 0.8 metres from the pivot. What is the moment of block B about the pivot of the beam? And what does the force produced by block A need to be for the beam to be in balance? So the first part of the question asks us what is the moment of block B about the pivot of the beam? So it requires us to recall the moment equation, which is as follows. The moment of a force equals the force times the perpendicular distance to the pivot. It's already a perpendicular distance, so we can just call it distance. So we know that the force, which we've been told in the question, is 280 newtons. We know that the distance is 0.5. So our moment is 140 measured in Newton meters. Now, the second part of the question asks us to think about what the force of A might be if the beam was to be in balance. Now, for a beam to be in balance, it needs to have an equal moment on one side to the moment on the other side. So both sides need to have the same kind of moment. The moments need to be equal. It's otherwise known as the rule of moments, which is moments clockwise equals moments anti-clockwise. So the moment that we have on the right, which we've just worked out, is 140 Newton meters. So we need to make our moment on the left equal 140 Newton meters. So we are trying to find a force. So let's rearrange our equation for force. When we do that, we get that force equals moment divided by distance. Now, we can substitute in the values that we have. So force equals moment, which is the moment that we've just found out, 140, divided by distance, which is 0.8. When we divide them by each other, we get that force on the left is 175 newtons.